All right, today we're going to begin with 1.1D, solving simple equations. And this is the first day that I can say that we are most definitely not doing review. We are solving simple equations today. This is really the first lesson we're going to have that's actually out of the book. So this is actually what section 1.1 is. And we have to worry about solving equations. And solving equations has many, or rather a number of parts to it. Now, the first thing we can do is we can talk about our goal. This is what we're striving toward. What we're attempting to do, our goal, is to get variable alone. So this could be x, for example, maybe y, could be pretty much any letter. It's almost always a letter though. And when we say that we're trying to get it alone, this could mean that we are trying to isolate the variable. That's something that you'll hear me say quite frequently. I say we're trying to get a variable alone, we're trying to solve for it, we're trying to isolate it. Now, there are a number of very important properties to how we do this. One of them is do the opposite. Do the, and I'm running out of space, I can see, opposite. This means that we are doing opposite operations. So this is inverse operations. So when I'm talking about inverse operations, which went off the screen a little bit here, let me move this over. When I'm talking about inverse operations, what I'm referring to is addition and subtraction are opposites. So if you have something that's being added, you want to subtract it. Likewise, multiplication and division are opposites. If you have something divided, you want to multiply to get rid of it. So if we were to write this down quickly for our inverses, we have subtraction and addition, and we have multiplication, which I'm going to use the dot for, and division. These are our opposites. Very important to remember this. But when we do our opposite operations, it's not just a matter of doing an opposite operation. Part of it is that we have to do the same operation on both sides of the equal sign. That's our equal sign. And our properties of equality are just like our inverses: addition, subtraction, multiplication, and division. And as we spend more time in this class, we'll eventually add additional operations we can do to our toolbox that will allow us to do absolutely everything that we need to solve equations with all the tools that we have available. Okay, and then we have one more thing to look at, and that is distribute. And this is sort of like some miscellaneous operations that don't really need to be done to both sides because they're just stuff that's on single sides. But it's stuff that we're going to have to watch out for, so I'm going to include it here. But these come up, I would say, not quite as consistently as all the other ones, but still they're extremely common and important. And this is things like distribute, which we'll see in some problems eventually. Combine like terms. Which we'll also see quite commonly. And when we have multiple variables. This one will not be too much of a problem. Most of the time we have multiple variables, it will just be multiple versions of the same variable, like several x's. But once we start talking about lines, we'll have both x's and y's running around, and we'll have to know what we need to do with each of them. But that's something that we pretty much get to save until we reach chapter 1.5, which I'm sure will be super fun. But we're going to go ahead and do a handful of examples solving various one-step equations. That's why they're called simple. When we say simple, we pretty much just mean it takes one step to solve them. And this is something that can give you a big hint in this chapter, is when you're trying to solve a one-step equation, you should probably think, okay, I should only have to do one thing and then get the answer. And if you can do that, you'll be in mighty fine shape. So let's go ahead and take a look at some of our example problems. So, for example, 1, you can't see where I wrote example, but this is number 1, we'll have A and B. Part A, our first problem will be x minus 3 equals negative 5. So if we think about what we just learned, our goal is to get our variable by itself, and the variable in this problem is x. And we need to do an inverse operation, or the opposite, in order to get x alone. And if we look at this, we have x minus 3. The operation that causes something annoying to be attached to x is this minus 3 here. And what's the opposite of minus 3? It's addition. So we're going to add 3. However, what we do to one side, we must do to the other. So when we add 3 to the negative 3, we must also add 3 to the other side of our equal sign. So we have negative 5 plus 3. Now, the whole reason why we add 3 to the left side is because negative 3 plus 3 is 0, and x plus 0 is x, because 0 can be combined with anything and it doesn't change anything in that way. So here, on our left side, we're now just left with x. On our right side, we have negative 5 plus 3. You might want to take a moment and review your integer addition so you can come up with a negative 2. So that only took one step. Let's look at example B. Example B, we have 9 is equal to y plus 28. And this problem is just like the one we just did, except this time, instead of having a number being subtracted from our variable x, this time we have a number being added to our variable y. So again, we need to do our opposite operation. And what's the opposite of subtracting or adding? Well, it would be subtracting, because we added to undo a subtraction here, so now we need to subtract to undo an addition. So we're going to subtract 28 from both sides. This leaves us with y is equal to, since 28 and 9 have opposite signs, and this is a subtraction problem, we can treat it as if it's 28 minus 9. 28 minus 9 brings it down to 19, and since negative 28 is much larger than our 9 is, our answer will be negative 19. All right, these are both relatively straightforward examples, and we are going to go ahead and take a look at a couple of more examples. So, for example 2, we'll start with A. And on this one, we're going to have negative 3x equals 12. And what we now need to consider is, how do I solve for x here? Now, in the first problem, we added to undo a subtraction. In this one, we subtracted to undo an addition. But we need to figure out how negative 3 is attached to x. Negative 3 is a coefficient on x. Coefficients are when we have a number just sitting next to a variable. In this case, what this means is that we need to do a division operation here in order to undo the minus 3. So we need to divide both sides by negative 3. Take a moment to consider what the solution to 12 divided by negative 3 will be. When doing the division of 12 divided by negative 3, what we're going to end up with is 12 divided by 3 essentially, and then we need to pick what sign we're going to have. So 12 divided by our negative 3, divided by a 3 is going to give us a 4. So we're going to end up with x equals 4. And since the 12 is positive and the 3 is negative, it will end up being a negative 4, because when we have different signs in a division or multiplication, we get a negative answer. This also brings an important point to bear here, which is thinking about negative 3 divided by negative 3. When you divide negative 3 by negative 3, or indeed when you divide any number by itself, like 17 divided by 17, 11 divided by 11, every time you do this, what you get is 1. So that means what we actually have written here is 1x. That's not supposed to be a Roman numeral, that's 1x. And the important thing to recognize is that 1x equals x. This is going to be a common problem that you'll come across over and over and over again. When a letter, a variable, does not have a number attached to it, its coefficient is assumed to be 1. And being mathematicians and wanting to be fast, we just leave the 1 off because it is implied. So sometimes you'll be asked what the coefficient on a variable is that doesn't have 1. In this case, it is a 1. All right, we have one more example. Maybe we'll make it 2 more examples. This is going to be y divided by negative 5 is equal to 2. So this one is pretty straightforward as well. In the last problem, what we did to undo negative 3x was to divide by negative 3. Since we're already dividing by negative 5, you guessed it, we're going to have to multiply by that negative 5. I'm going to go ahead and rewrite this on the second line so I have a little bit more space to do the multiplication by negative 5. And I need to do the multiplication by negative 5 on both sides. These negative 5s will cancel out. Therefore, we will be left with y is equal to 2 times negative 5. What's 2 times 5? Take a moment, pause if you need to, it's 10. And since this is a positive times a negative, once again our answer will also be negative. All right, we're going to look at one more very tricky example. And this is something that will come up a lot, and you'll get plenty of reminders about, but this will be negative x equals negative 2. Now, in order to solve this, we need to get the variable completely alone. And in all the previous examples, we were able to divide something out, multiply, add, subtract, and we would always end up with just an x, just a y. But this time we have a negative x, and we need to ask ourselves, well, this is something that it's a coefficient because it's just sitting next to the x. So we need to figure out what can we do in order to get x alone. Well, in order to figure this out, you need to recognize what is actually going on here. This is actually implied to be a coefficient of negative 1. So in the same way that a regular x is implied to have a coefficient of 1, when you have a negative x, its coefficient is actually going to be a negative 1. And from here, solving this is pretty straightforward. You just need to divide both sides by negative 1. And in this example, what that gives us is x is equal to a positive 2. So that was a lot today. You're going to have to keep an eye on what opposite operation you're going to need to choose to do to solve these simple equations. And also do a very good job of paying attention to what the coefficient on our variables are, especially when it's not something super obvious like a negative 3, and instead is a negative sign, or there's nothing there, in which case you have a 1. All right, that concludes our video. Good luck on the assignment.